14.8 Applications of Quadratic Equations. On example 1, it says the length of a rectangular room is 2 meters more than the width. The area of the floor is 48 square meters. Find the length and width of the room. Okay, so notice we're talking about a rectangular room, so the first thing you would do is draw a rectangle if a picture is not given to you. And then it says the length is 2 meters more than the width. So if we labeled the width x, the length is 2 meters more than that, which is x plus 2. Now in this case, the dimensions, the descriptive dimensions were given to you. If they're not, then you would have to write those in. You would have to draw your picture and write them in. And then the other information they give us is the area of the floor is 48 square meters. So for a rectangle, area equals length times width. So 48 equals the length, which is x plus 2, times the width, which is x. Okay, so then multiplying that out, we can distribute the x. So we get 48 equals x squared plus 2x. And then as a quadratic, we need the set equal to 0. So I can subtract 48 from both sides, giving me x squared plus 2x minus 48 equals 0. Then I would want to factor this. So that's x times x, and 48 would be 6 times 8. I need a positive 2, so that would be 8 minus 6. So setting each of those equal to 0 gives me x equals 6 and x equals negative 8. Since we're talking about dimensions of a room, we can only have the positive. So that means that the width is 6 and the length is 6 plus 2, which is 8. Example 1b says the length of each side of a square is increased by 4 inches. The sum of the areas of the original square and the larger square is 106 square inches. What is the length of a side of the original square? Alright, so on this one, a picture is not given, so I'm going to go back and start looking at it from the beginning. I usually have to read the problems twice, once to get an idea of what it is, and then the second time to go back and look at specifics. So we're talking about a square, so the first thing I'm going to do is draw a square. The length of each side is increased by 4 inches, which means that I'm talking about an original square and then a new square. So if the original side lengths were x, and then the length is increased by 4, so the new one is going to be x plus 4. And notice it's a square, so it's going to be those dimensions on the length and width. The sum of the areas of the original square and the larger square is 106. So the sum of the areas. So if I look at the original, the area is length times width, so x squared. And then on the new one, the area is going to be x plus 4 times x plus 4, or x plus 4 squared. And it says the sum of those areas is 106. So my equation would be x squared plus x plus 4 squared equals 106. So I'm taking this area plus this area equal to 106. Okay, so x squared plus, when I multiply x plus 4 squared, remember that's x plus 4 times x plus 4. You need to use FOIL for that. So x squared plus 8x plus 16 equals 106. And then we can simplify this, so that's going to be 2x squared plus 8x plus 16 equals 106. Subtract 106 from both sides. We need this equal to 0. So it's minus 90 equals 0. Alright, and then I'm going to factor this. So notice that I do have a GCF of 2, so I can factor out that 2, which would leave me with x squared plus 4x minus 45 equals 0. And now I'm just going to factor the x squared plus 4x minus 45. So there's still a 2 in front. That would be 9 times 5. So 9 minus 5 is 4. 9 times negative 5 is negative 45. So then setting this and this equal to 0 gives me x equals negative 9 and x equals 5. Again, since we're talking about side lengths, it's going to be the positive. So the side length of the original square is 5 inches. Example 2 is dealing with consecutive numbers. So before we get started, just a couple things that you need to know is that when we're just talking about any consecutive numbers, you're always going to have x and then x plus 1. If they ask for 3 consecutive numbers, x plus 2. If they ask for consecutive even numbers or consecutive odd numbers, it would be x and then x plus 2, and then if they wanted 3 consecutive even or 3 consecutive odd, it would be x plus 4. Now notice this is for consecutive even and odd, because to get from one odd number to the next, you add 2. So like if I start with the odd number 21, I have to add 2 to get 23. Add 2 more to get 25. So it's not plus 2 plus 4 because those are even numbers. It's because it's every other one is an odd number or every other one is an even number if you start with an even. So this first x plus 1, x plus 2 is just for consecutive numbers. X plus 2, x plus 4 is anytime it's consecutive even or consecutive odd. Alright, so the product means we're going to be multiplying of the numbers on 2 consecutive lockers. So that means I'm going to have x and x plus 1 at a health club is 132. So the product is 132. Find the locker numbers. So x times x plus 1 equals 132. So there's the product by multiplying them equals 132. So then I can distribute the x, which would give me x squared plus x equals 132. Set that equal to 0. X squared plus x minus 132 equals 0. I can factor that. 132 is 11 times 12. So x minus 11, x plus 12, which would mean x equals 11, x equals negative 12. So these are locker numbers, which are going to be positives. So the x would be the first one, and so the next locker number would be 12. So the two numbers would be 11 and 12. Example 3, the product. So again, that tells me I'm going to be multiplying of 2 consecutive even integers. So consecutive even means I have x and x plus 2 is 4 more than 2 times their sum. So 2 times the sum, so x plus 2 plus 4 more. And then here I have the product of that is. So the product, x times x plus 2, is 4 more than 2 times. So 2 times the sum, x plus 2 plus 4 more. So x squared plus 2x equals 2 times 2x plus 2 plus 4. So distributing the 2 would give me 4x plus 4 plus 4. Remember, bring that down. So it's going to give me x squared plus 2x equals 4x plus 8. Then setting that equal to 0, x squared minus 2x, because I'm subtracting 4x from both sides. So minus 2x, subtracting the 8, equals 0. So then factoring that, two times 4, negative 4 plus 2. So that means it's going to be x equals negative 2 and x equals 4. Okay, so in this case there were two possible sets of consecutive even integers. So the first one, you could have negative 2 and the next even integer after that would be 0, or 4 and 6. Find 3 consecutive odd integers such that the product of the least and greatest is 16 more than the middle integer. So when I have 3 consecutive odd integers, that means I'm going to have x plus 2, x plus 4. So to get from one odd to the next, you add 2, and then 2 more. The product of the least and greatest, which would be x and x plus 4, so product means times, so x times x plus 4 equals 16 more than the middle. So the middle is x plus 2 plus 16 more. Alright, so then distributing the x would give me x squared plus 4x equals x plus 18. Setting this equal to 0 gives me x squared. I'm subtracting 1x from both sides, so plus 3x. Subtracting 18 equals 0. So then we'll factor that. So that's going to be x times x, 3 times 6, and I need a positive 3. So then x minus 3 equals 0, so x equals 3. X plus 6, so x equals negative 6. And so remember that we are finding consecutive odd integers. Well, negative 6 is not odd, it's even. So the 3 consecutive odd integers would be 3, 5, and 7. Example 4. The hypotenuse of a right triangle is 3 inches longer than the longer leg. The shorter leg is 3 inches shorter than the longer leg. Find the lengths of the sides of the triangle. Alright, so whenever they're referring to something, they're comparing it to something, that's the one you're going to label X. So we have information about the hypotenuse and the shorter leg, both in reference to the longer leg. So the longer leg is X. The hypotenuse is always the one opposite the 90-degree angle. It's the longest side, so 3 inches longer than the longer leg, so it's going to be x plus 3. And the short leg, which would be this one, is 3 inches shorter than the longer leg. So shorter is going to be x minus 3. Alright, so when we have a right triangle and we know the sides, we're going to use the formula a squared plus b squared equals c squared. So it's going to be, it doesn't matter which one's a and b, c is always the longest side, the hypotenuse. So x squared plus x minus 3 squared equals x plus 3 squared. So x minus 3 squared is x minus 3 times x minus 3, so x squared minus 6x plus 9 equals x plus 3 squared is x plus 3 times x plus 3, so x squared plus 6x plus 9. And then we're going to simplify everything and get it all equal to 0. So this side will be 2x squared minus 6x plus 9 and then subtracting x squared would give me 1x squared. Subtracting 6x would give me minus 12x, and subtracting 9 would give me 0. So then to factor this, they have a common factor of x, so then that's x minus 12. So then x equals 0 and 12 equals 0. So if x is 12, then 12 minus 3 is 9, and 12 plus 3 is 15. So the three sides of the triangle are 9, 12, and 15. The number of impulses fired after a nerve has been stimulated is modeled by I equals negative x squared plus 2x plus 60, where x is in milliseconds after the simulation. When will 45 impulses occur? Do you get two solutions? Why is only one answer given? Okay, so let's answer the first question. When will 45 impulses occur? So we're going to write this as 45 equals negative x squared plus 2x plus 60. So if I move everything over to this side, then that's going to be x squared minus 2x, and then subtracting 60, so negative 60 plus 45, negative 15 equals 0. Three times 5 is 15, negative 5 plus 3 is negative 2, so x equals negative 3 and x equals positive 5. So when will 45 impulses occur? After 5 milliseconds. Yes, we got two solutions when we solved it. We're only giving one answer because it doesn't make sense to have a negative in this context. When we're talking about time, we don't have a negative amount of time. So 5 milliseconds is the only answer that makes sense. Use a model in example 6 to find the foreign-born population of the United States in 1990. Give your answer to the nearest tenth of a million. How does it compare to the actual value from the table? Okay, so the model in example 6 is y equals 0.01036x squared minus 0.5316x plus 15.36, where x equals 0 represents 1930, x equals 10 represents 1940, and so on, and y is the number of people in millions. So we're going to use that model to find the foreign-born population of the United States in 1990. Alright, so given this information, if x equals 0 represents 1930, and 10 represents 1940, 20 would represent 1950, 30 would be 1960, 40 would be 1970, 50 would be 1980, 60 would be 1990. Okay, so this is going to be where x is 60. So plugging 60 into x in the equation gives us y equals 0.01036 times 60 squared is 3600 minus 0.5316 times 60 plus 15.36. Okay, so calculating all that gives us y equals about 20.76, which is about 20.8 million. It's tenth of a million, so 20.8 million. And then it says, how does it compare to the actual value from the table? Okay, so here's the table, and we're looking at 1990, so it was 19.8, so that was the actual 19.8 million, and then our calculated was about 20.8, so our calculated answer was a little bit high compared to what the actual data was.